Measurement of soil moisture. So we can measure the soil moisture, as I told in the class, by different approach. The basic method is gravimetric method, what you have already learned, I guess, in your second year, but today we will as well learn this and use this to calibrate all other secondary methods of measuring soil moisture. So soil moisture, either we can measure directly by any instrument which is calibrated to show you the volumetric content of soil moisture, or it is measured in terms of hydraulic head or suction head in the soil. That is basically by using tensiometer. But you know that tensiometer has a limit of certain level, 0.8 atmospheric head, we can measure a maximum. So let us see first, this is the oldest method and it is obsolete now. It is not used now or not supposed to used now, and this is hydroprobe or neutron probe. Basically we have very low capacity neutrons. Americium, beryllium is used to generate very low level of neutrons, low energy neutrons, which is once colliding with the hydrogen ion of water available in the soil, it is absorbed and the remaining neutrons are reflected back. So the probe has 2 points, radiation point which radiates low energy neutrons and collects back. So number of collected back neutron, or say simply the count, gives you how much soil moisture is available. So it was used earlier to measure the soil moisture, but now it is no more in use, and if you are or we are using, the paper or writing will not get accepted, so it is closed, not used. But for your understanding, you please write the theory of hydroprobe or neutron probe method of measurement soil moisture. Let me show you other two methods. One is tensiometer and another is FDR method. How we can use, or we are using in our farm, to find out what is the soil moisture at the current condition. And these two methods we will calibrate or we will compare by using the gravimetric method of the sea. Now these are the tensiometers we have fitted already for our observations or experiment at 30 centimeter depth, 45 centimeter depth and 60 centimeter depth from the top surface. What is tensiometer? You have already learned in your theory. It has a porous cup and it has a tube. Tube is filled with water. Cap is, once it is filled with water, we put a cap to seal it from the surface, from the top. And because of dry condition of soil tries to exert a pressure, suction pressure on this cup, which allows water to make a kind of balance between moisture content of the soil and the water inside. So once moisture or water is getting out from this porous cup, it creates a suction in this tube. And if we measure this suction in this tube by using any approach, we can find out what is the suction condition of the soil or hydraulic head of the soil at the depth we have installed this porous cup. That we can calibrate. We will give you, I will give you the calibration curve to find out the moisture content in terms of hydraulic head we have measured in the soil. So you can find out at this particular hydraulic head, this is the moisture content of soil. And then you can compare with other two methods, gravimetric method, that is the basic method, and FDR method. So let us see how to read the suction inside the tensiometer. So we have a device. So to read out the tension or suction pressure created inside this tensiometer because of hydraulic head of soil or suction of soil, we have this readout unit which has a opening. So we have a guide to this opening once we are putting this, and this is a special rubber cap which punctures by using this injection syringe near about 100 times, and it is not allowing air to get inside this tensiometer tube. So we can measure in terms of millibar suction head that is created by this soil because of soil moisture content, less soil moisture content, and this millibar suction we can use calibration curve to find out what is the soil moisture at 30, 45 and 60 centimeter depth of the soil. Now let us measure the suction head inside. So now we can see tensiometer reading 0338 millibar, right? So this is 336 millibar suction head created at 30 centimeter depth. Now let us see at 45, 278, just wait for 2 seconds. So it is finally 288 millibar at 45 centimeter depth. At 60 centimeter depth it is 162 millibar. So 336, 186, 7, 186 and 163 millibar at 60 centimeter. So we can find out what is the soil moisture of soil by using tensiometer when we have measured the suction head at 3 different depths. What we use? We use calibration curve to find out soil moisture content in volume or volumetric soil moisture content. We can find out from the calibration curve of these tensiometers. So this is FDR. We have a bulb which has a dimension of 5 centimeter near about, and it has a scale. So this is, once it's a closed arrangement, it has a scale to go inside access tube for 10 centimeter, 20 centimeter, 30 centimeter, 40 centimeter, 50 centimeter. We have to correct this scale with respect to this tube which is over this soil surface. So let us measure this. It is near about 19 centimeter. You can see 19 centimeter over the ground surface. So 19 plus whatever scale we are interested to find out, just like 30 plus 19. So 49 centimeter once we are inserting, it will be at 30 centimeter depth of soil moisture measurement. So now you can see it has a bulb which uses frequency domain. Frequency is created to measure the soil moisture. These are 2 sensors which measures the frequency, and it goes inside, and it has a readout unit here which is connected to give you directly the soil moisture in terms of volumetric unit. So now let us see what is the soil moisture in volumetric unit at different depths. So for 30 centimeter we need to insert this up to 49, you can see, and at this top surface here. So it is now exactly 30 centimeter depth soil moisture it is measuring. So see in the readout unit it is giving how much it is, 26.1 millimeter per 10 centimeter. So it's a 26.1 percentage of soil moisture. 26.1, finally it is 26.012, but finally it is 26.1 cubic centimeter of soil. 26.1%. Now let us go to 45 centimeters. So 45 plus 19, 64. So let us go 60. 1, 2, 3, 4. So here, let us see what is the soil moisture. Here it is 32.576, 32.567 it is showing. So we can take 32.6%. Now let us go to 60 centimeter. So 60 plus 19, 79. It is going to 79 centimeter depth, and here, and we can find out what is the soil moisture. This is giving 35.1%. So now in this way we have soil moisture for 30, 45 and 60 centimeter depth of soil by using FDR method. It is in percentage. We got intensiometer in terms of hydraulic head or suction head, and we used gravimetric method to find out or to compare these three methods of measuring soil moisture or soil potential to find out whether this is sufficient moisture for crops for practical purposes or we need to supply irrigation. So next experiment we will learn how and how much irrigation we need to supply by getting the information about soil moisture. So now let us take the gravimetric moisture sample, because this is auger which is collecting soil moisture from different depths, and this is the portion where we will get our sample. So let us measure from here 30 centimeter, 45 centimeter, this is screw, so we have better observation, and from here 60 centimeter here up to this. So these are the points. If we are inserting this auger inside the soil, we will get sample from 30 centimeter, 45 centimeter and 60 centimeter, and collect the sample to compare with the soil moisture we have measured or we are getting from tensiometer and FDR method. So let us take the samples. So now it has reached to 60 centimeter, a little more, 30 centimeter, sorry, and we need to take the sample from here, collect in this box just few gram of soil to get the soil moisture at 30 centimeter, like here. It is sufficient. So this is sample to find out soil moisture at 30 centimeter. We need to put this sample in the oven at 105 degrees Celsius for 24 hours to find out what is the soil moisture. So we will weight this box before putting to the oven and after getting dried up from the oven after 24 hours. Let us take another sample from 45 and 60 centimeter. So now we have samples for 30 centimeter depth, 45 centimeter depth and 60 centimeter depth. Before putting samples to oven is working at 105 degrees Celsius for 24 hours to remove the soil moisture. We need to find out what is the weight of soil plus these sample box for all. And after 24 hours we will measure what is the weight of sample plus dried soil. Then we will remove the sample and find out what is the weight of empty box to find out what is the exactly soil moisture that was absorbed in this amount of soil, to find out finally what is the volumetric content of soil, volumetric content of water in this soil. So let us wait. For 30 centimeter it's 00 initially, 00 gram, 00, and let us put this here. So it is 64.55 gram for 30 centimeter depth. Now correct this This is sample for 45 centimeter soil depth. We can see the weight is 69.60 gram of soil plus sample. Now again tear this to make it 00, and this is sample for 60 centimeter depth. We can see the weight of soil, wet soil plus box is 98.51 gram. Now let us put these samples in the oven for 24 hours. Working oven at 105 degrees Celsius, and then we will measure again the weight of these samples. Okay, so now we need to put these samples in this oven. We are putting this samples, we need to open, put here, open so that all moisture is removed. Here, close this. These samples should be dried for 24 hours. So samples are put here, and you can see temperature is 105 degrees Celsius here, and we need to run this oven for 24 hours to remove almost all the moisture from this soil, and then we will wait it again to find out what is the volumetric content of moisture in the soil. Now after 24 hours drying of these soil samples in this box, we need to measure the weight of dry soil plus box. Now it is 00, the balance reading. So let me put box plus soil, that is 60.11 gram box plus dry soil. Now come to the 45 centimeter, let me put here, this is 00 gram, 00. So dry soil plus box, that is 64.04, 64.04, and the box plus dry soil of 60 centimeter depth, let me check, it is 91.36 gram. So let us remove the soil and find out the weight of empty sample boxes. So this is for 60 centimeter depth box, and weight is 38.59 gram. 38.59. Okay. This is for let us go for 45 centimeter first. So it's a 45 centimeter box. Removing the soil and taking the weight, that is 19.62 gram. 19.60 gram basically, 60 gram. Now, and this is third for 30 centimeter soil sample, 30 centimeter, and this is 00. So this is 20.85 gram. So this is gravimetric sampling method. We need to take the weight of wet soil plus box, weight of dry soil plus box, and weight of soil box or soil sample box to find out the soil moisture in terms of volumetric content in the soil. So you can compare now all three methods: gravimetric method, by tensiometer method, and FDR method. So in these three methods you can find out whether these two secondary methods are working fine with the gravimetric method. Thank you.